Yeah, you're perfect, Stan.
Okay. All right. Well, where shall we start today, he said.
What now, Dr. Morbius?
Prepare your minds for a new scale of physical scientific values, gentlemen.
The deeper a thing is, the more interesting.
Anti-gravity. Most physicists don't know the story.
We still don't know much more about this in the white world.
I've never heard of it.
The more I ask why,
it's probably classified physics.
It gets interesting.
The role of aerospace companies as holders of potentially basic scientific knowledge not shared with the academic world. Is it possible?
Maybe wrong, but it's true.
It's the bit of electrodynamics you're not allowed to know.
It is true. You believe it's true.
Yeah, I know it's true.
Disruption is coming.
Excellent. Yes, I would like to start with some questions from Mr. Greenyer. I'll work on my microphone situation, but please, Bob, would you like to ask your questions?
You sound better, Nate.
Yeah, you sound better. It's good.
Thank you, Nathaniel, for that. Stan, I've been a great admirer of your work since I first saw it. So thanks for joining us here today. I'm a practical applications guy and working with various scientists around the world to deliver various iterations of technology that I think that you have, certainly from what I've seen of what you said, a pretty good understanding of. And so I guess my first question would be, just not to beat around the bush, what would you consider the top 3 practical applications based on your understanding, and what limitations are there for those applications?
Applications of what?
Of your understanding of, I would argue, magnetohydrodynamics, let's say.
Wow, big question. Well, point one, using a MHD coil, you can interfere or intersect with the Earth's gravitational field, the vibrational rate, and you can draw power out of the gravitational field of the Earth, or whatever field you're in. Secondly, because inside of a vortexual field formed in one of those situations, you dilate time so that time passes either faster or slower inside the center of the coils, which can mean, delaying an operation or, a military or physical or whatever until you've got the answers you wanted, and then reverse the field, because time outside the craft, the field of the craft, is opposite to the one inside the field. You can use it obviously for travel, and you can achieve warp drive using that because space is a fluid. There's just no question about that. I don't know why there's any argument still remaining out there, but let's see. And using, let's see, do we have to use that for food replication? No. Okay. Those are the 3 main things. That's what you asked. So.
Yes, Stan, I would completely agree with that assessment. And what would you say would be the limitations of those 3 applications?
The limitation. Well, depending upon which, you can adjust for that. I was going to say, depending on which gravitation field you're operating in, galactic or stellar, planetary or what, you change the frequency of your equipment, and it might be that some of it is a little bit bulky or too miniaturized, either way. But for the operation here on Earth and what we're doing in local space, limitations are basically avoid electrical storms. Don't get in a situation where you can short out the field. That happens sometimes. You get too close to the ground or something else, and you haven't reversed the field yet. These are things that you learn, over time. But some of the earlier experiments did cost a crew or 2. Let's see. We can do that.
On those 2 points, I completely agree.
I remember the first test they did with Teller's group. I think it was in the late 60s. They set up the first craft, the 30-foot diameter one, And they put the computer recorder, the tape recorders and computers, everything inside that they had. They were very crude, and a clock. And they took off heading for Florida from. They were in Arizona or Nevada, I think, that time. Anyway, they took off, and they had calculated at the speed they would achieve how long it would take to get to Florida, and then they switched. Oh, take it back. They weren't going from Nevada to Florida. They're going from Nevada to over near Central Texas. And when they switched the field off, they had overshot the runway and went to Florida because time alters inside the craft. And that's for all physical operations, which, the tick-tock of the clock was, operating at a different rate than outside time. So anyway, they managed to make an efficient timepiece inside the field and be able to relate to external time.
That is fascinating, and the concept or the statement you made about having problems near electrical storms, I would fully agree. So with that whole subject about the time thing, does it affect consciousness whilst you're in there?
Well, I've never written in it, but as far as I know, no. It does alter everything equally. It spins up the atoms, adds energy, increases the relative spin of all the parts of the atom, which is really concentric spheres. And so your ability to think and speak and whatever is not affected as far as I know. Everything is equally affected inside the field. Remember in the biblical accounts of Ezekiel, when a flaming chariot came down through the skies, right?
Mm-hmm.
Okay. Yeah. It's punching through from a parallel universe where the atoms of that universe are much more energetic. They store much more energy in their spin. As a result, when you come down to our level, a level down from that area, you have to throw off the excess energy. And there's a process you do to unload the excess energy. And that's what makes everything flaming and burning looking outside, is because they're dumping a lot of energy into the atmosphere until they've done enough, and then they come down and land, and you can talk to them. Even in the Bible account of Jesus in the garden, when he had arisen, and that first moment or whatever, first day, Mary comes running up to him and says, "Oh, Master, Master," and goes over to hug him. And he says, "Stop, don't touch me, for I have not yet ascended to the next universal level." He was charging up. And so it would have harmed her body if she touched him at that point. So these examples do kind of illustrate the differences in spin energy differences.
So if there's a difference between one realm, let's say, for sake of an argument, and another, is it a consistent amount of energy you can get, for instance, when you're near condensed matter in, say, the Earth, or within gravitational bodies like the Earth, the Moon, and the Sun, and interstellar space? Are you able to secure the same energy, or is it slightly different?
Think about that and ask that question again. I'm not sure I followed it correctly.
So basically, you're saying that this descent of in Ezekiel, they were overcharged because they were coming from somewhere else on a related subject.
Well,
is it the case?
And also, sorry, go on.
You're not near a gravitational body, and you're just going within our universe between, galaxies, let's say. Would you imagine there's a different ability to harvest energy in the interspace distance?
Well, I think that gravitational waves permeate the universe from all sorts of places. You'd probably want to adjust by a dial to search for frequency ranges that are like, if you're going intergalactic, to search for long wave frequencies in that until you get a hit, because you'll get several hits. It's like tuning a radio, and you tune to the local source of gravity. And once you're locked into that, then you can start extracting the energy with a beat frequency between your own field and that field.
Okay, so that's very interesting, because this whole tapping into energy, you mentioned the sort of, I can imagine like a Tesla, Wardenclyffe Tower type affair, extracting energy from the Earth. You talked, I think, sometime about this facility in Australia called Pine Gap.
Yes.
wireless energy. Could you speak a bit more to the technologies or mechanisms that Pine Gap was using to enable wireless power transmission?
Well, it's past tense. I don't know what they've done since I've been out of the country, but during my time there, they had had a water well driller guy in Adelaide drive up to the Gap and with his equipment and drill a 5-mile deep water well underneath Pine Gap.
Oh.
That was the ground. And by using that deep ground, they could communicate with submarines and things like that at different frequencies. It was a Tesla coil on the top. They had the ball. I mean, I've got photos of the stuff, but from the ground level. And that was one of their big classified secrets, was that deep water well. They got really angry when I published that, but anyway, I don't know what they do now.
Or maybe I should know where you published that. Where did you publish those photos?
Oh, might have been on Coast to Coast or something. I just published the fact that they had that water well. I might have even put it in the Cosmic Conspiracies that long ago.
Oh, wow. Okay. All right. Well, I'll have to look into that. So, there's a lot of people out there that I have worked with and I've visited who've claimed various free energy systems. Some have shown a lot of promise, but in your work, have you been able to create sort of a free energy system that's been able to be replicated by third parties, and have you shared actual experimental protocols? Because I don't know if you're aware that our project is an open project called the Martin Fleischmann Memorial Project, and we've shared many open procedures to create expected outcomes, which include over unity thermal energy generation, and also transmutation of elements. Have you done, because we've had more struggle generating direct electricity.
All right.
All
right. Here's one thing. There are several sources of electrical energy. Anywhere where you have relative motion, you can generate electricity.
Yes, of course.
Yeah. Now, in our situation here with the sun, it's constantly putting out bursts of solar wind, which wax and wane. As that solar energy impinges on the Earth's atmosphere and the charged envelope around the Earth, it creates, a frequency of high voltage in the atmosphere, and so that weakens at nighttime, and you lose about 25% of the energy in that at nighttime. But direct sunlight, you get it at full bore. Not a big drama. You can adjust for that. But let's see. Henry Moray did do that, and he was before semiconductors and diodes and stuff were as modern as ours.
He made a type of kind of like almost like a hairpin diode, didn't he, to try and extract from the source, because he had a static charge collector.
Yeah, that little can, he put the little modules of different elements in. Yeah.
Yeah, and then he had a series array of vacuum tubes.
All right. Well, let's forget his thing. He was looking for it in the way he had available. Let's look at it modern day. You've got a high voltage electrical current coming in. It's a direct vibration. Okay. How would you intersect a high voltage frequency, say 2 or 3 megahertz? How would you intersect that here on the ground?
You'd probably have some sort of coil system, I imagine, something to interact with.
Well, suppose that you did this. Suppose that you put up an antenna, say 80, 90 feet long, stretched sideways, horizontal, and you charged that antenna, say, to 18 to 20,000 volts, because we know that over that it's going to start leaking in the atmosphere. You charge that, and you start monitoring that antenna with what my tests were. I had the wire coming into the house into a frequency generator. But anyway, listen to that. Listen and tune it to where you're getting noise, at a certain frequency or a range of frequencies. And the trick is, okay, once you can detect that vibration coming from the solar wind impingement on our atmosphere, then you build a device. It's like a Tesla coil, but you're doing like Tesla said, is you're collecting that energy, and you're rectifying it, and you go over to a work area. In fact, I think I put that in my harmonic energy exchange patent application, which they denied because they said, but it's still up on the internet. Stan Deyo harmonic energy, you can look that up. But anyway, it's basically you collect this high voltage variation on your antenna, and as it varies, you put it through a spark gap, and you have an inductor coil and capacitance tuned to that to pull it off into usable voltages. I'm just trying to see here if I've got.
I like what you're saying because there's this Russian scientist called Shishkin, and he argues that this energy that is produced and rains down from the cosmos, and he would argue that Henry Murray and Tesla and all of these systems are engaging with this. It's kind of like a neutral type of electricity that's in neutral clusters that can then be excited by either something like silver powder, for instance, or a charged metal surface, and that converts it from the neutral state into a white state. And he actually says it's actually what static electricity is, and that then these structures will travel down a wire, and then they can be made to blow up. And when they blow up, they produce what Kenneth Shoulders determined was about 10 to the 11 electrons per cluster. And in many respects, this is what he claims is the kind of cold electricity that's harvested from the atmosphere that leads to the kind of process that you've literally laid out there in what you just said.
Well,
are you aware of Ken Shoulders' work?
No, I was looking up a while ago. I hadn't heard of it, but then again, I am active in so many fields at the moment, and it's no wonder.
Yeah, I'm sure you are. Yeah, so Ken Shoulders, he was the guy that invented the screening technology for microelectronics, and he looked into a guy called John Hutchison. Are you aware?
Yeah, Hutchison. Yeah, he put a lot of things in operation to try to get something out of it, a warping metal or whatever. But yeah, I'm aware of his stuff. Yeah,
he investigated John Hutchison at the behest of a guy called Hal Puthoff, and after about 5 or 6 years of work, he published a book called Electron Validium EV: A Tale of Discovery, which was discussing these clusters, which he called a perfect oscillating monopole. Does that sound something like you might have heard before?
I don't think I would describe it the same way. I'll tell you this: if you're on your computer now, and if you look at U.S. patent, that's US 2008 019 1.
Can you run me again? U.S. patent what?
Yeah, because they said it couldn't possibly work, so they wouldn't grant the patent, but they put it back up on the server.
Okay,
Stupid bastard.
Can you read really slowly so everyone can type it in?
Okay, that's it's United States patent, and it's an application rather than a patent, but it's still got a U.S. number, so it's US 2008 019 158 0A1.
Okay, application 1, yes, harmonic energy exchange device. Okay, I see your antenna. Okay.
Look at the left circuit there. The left picture, the first one, which shows, all the active parts.
You've got a spark gap in there with the diode.
Yeah, and you have this capacitive link, so that it charges up and dumps into this circuit that becomes an AC resonant circuit with an adjustable capacitor in the middle. The work zone being over here as a DC component. Now, looking at this circuit, they changed, a guy over in Georgia and his group changed the arrangement, but not the component, changed the arrangements because they used a ground loop ground. And the patent office gave them the patent to this, and they used mine as a prior art.
That just sucks so bad.
And not only that, look, I quit back in 2008 because I was talking to the inspectors at the patent office, and they said, look, the government back at that time had told them to recruit a bunch of college students to sit in as subsidiary patent analyzers to a single patent officer, and he would handle like 8 or 9 different individuals that weren't really qualified to, assess whether the thing is patentable or not. And so he says, you're going to get a lot of strange results with this kind of a crew. He said, and the Chinese have a China desk here in the patent office. And he says, I guarantee you, if not before, when it is released, they will have a working model better than yours on the West Coast in 2 weeks. So it just killed my soul. I mean,
did you make prototypes of this device?
Oh, I started it. My partner Tim and I had done that, Tim Carty, and in the process, we realized that we're drawing in the threat of lightning strikes onto our antenna because we're lowering the impedance in the air around it. So we thought, well, we need a shunt or something to take the high voltage pulses off the ground. Right. Okay, fine, fair enough. Well, we started getting bits and pieces in for that, and then we thought, hey, we can use this design we've got here for an EMP shield to ground EMP pulses, and we can sell that to make more money to do the research. So we set that up. Oh gosh, what was this? 2025, probably 2020, somewhere around there. You can look in the patent office thing for Stan Deyo and Tim Carty for EMP pulses or EMP things like that. You can see the patent. Anyway, and we formed the company, got millions invested, and to do that, we had to sell 51% of our shares over to all these different shareholders. And we went along fine for a while, selling to individuals. And then when Tim went to Washington and told the Defense Department about what we had, it complicated issues because we had to get into the Democratic Congress to get a what do they call it? A CHIPS Act grant of $3 billion. Anyway, the other board members didn't want that. They wanted to take over the whole company and kick us out. And so,
as usual.
We had a horrific thing. They even put armed guards outside of our board meetings so that we couldn't do anything nefarious. Not that we would do such a thing. And we had our attorneys watch these board meetings from external to see how they were handling that. And we gained enough evidence to perhaps sue them and perhaps incriminate them in a criminal case. But here we are. Tim died last year, had a heart attack. And they canceled his insurance over at the company, so he couldn't get any insurance cover for his wife. And it just threw, a wrench in what we were doing, because Tim and I were going to take money from the company, the EMP Shield, our fair earnings, and put it into making a model of this work. And we had bought in, I can't remember what type of crystal it was, one that Morey used, and we found some raw crystals of that type that we were going to try to make a diode out of that.
Right, Swedish stone or something.
Yeah, the Swedish stone, and I think we tracked that down to something like a sulfate. I'm not sure. I know I've got it wrapped out in the workshop because it's toxic to touch, so we had to be careful to that. And so when he died, my inspiration died, and I left all the pieces sitting out there, and so I haven't fired it up. In short,
Well, I'll tell you what, Stan, looking at this now, it reminds me of a patent or a proposal, and it's so old. It used radium, and what they did is they produced spheres which were inflated. They didn't have mylar at the time, so they had to create something that could hold gas to take it up to a very high. I think they even used hydrogen. And then they put all over it a load of spikes, and the spikes were as fine as they could make the spikes, and they were regularly spaced over it. And then they coated the tips of the spikes with radium. And they didn't really explain how it was meant to work, but it apparently really did work. And I can imagine that those spikes up in the upper atmosphere would do this process that Shishkin has now established, where the natural exotic vacuum objects act as static electricity, which is particularly there when you're in a dry desert area like Murray and Tesla did for a while. causes them to blow up, release those 10 to 11 electrons, and then the same spikes conduct that direct electricity down the spike. So it's like a hybrid of what you've got here and what Murray was doing. So I'm going to try and find a way to get that material to you, because I think that idea, it's already been out there. It can't be patented, but what I've got, you've got here, I think if you merge those two ideas, you could really have something. Don't give up, Stan, just because it's, you know, people have been.
Look, guys, I'm 80 now, and I'm wearing out.
Started.
Let me say this: the radium spikes and things that you're talking about, I think they were doing what we were doing with that charged antenna. Remember, Maury's device worked.
Yes.
And I talked with his son and with the engineer that made the diodes. I think they were made from silicon diodes. He made them. They were like the size of a water glass. They were big. And so in talking to all of them, I was convinced that the way they were interfacing to that high voltage was to make a tuned self-resonant circuit up there in the antenna. And that when you set it and then isolated it from ground, that it would start to store energy. And then you would reference it to ground through a capacitor, and obviously not let it get up over the 20 kV limit, and then trap it. Our method was not radium spikes, but a self-contained harmonic field on a wire, antenna wire.
Make complete sense. I mean, I would suggest using just a kind of like a modern high voltage Schottky diode rather than trying to recreate the. Anyway, thank you for putting.
Let me add one thing here. In our experiments with Van de Graaff generators, I found that I could take a 250,000 volt Van de Graaff generator and establish the field in it and float. Well, I used a couple of little ball bearing raceways, about 1 inch in diameter, and then a steel ball bearing on top of that. I put clay. What do you call it? Plasticine, or what do you call molding clay here?
Yeah. Well, yeah, plasticine.
Okay. Well, and that was to hold the ball bearing raceway on top of the big sphere, and then to hold the probably 3/4 inch steel ball on top of that. So what they did was focus the field around and up, so you could see those arcs jumping out into the air. And I found that I could take a piece of paper, imagine like a cigarette without any tobacco in it, without a filter, just a hollow paper tube. And I thought, if there is a field of electrons coming up out through the center and then curling back around, from inertia, that I should be able to make a paper diameter of that, say about 2 inches tall, and I should be able to place that in the air above that steel ball bearing, and that it would float. And this is a crude way to do it, but anyway. And I found that if I varied the voltage down into controls, the paper would go up and down and float. And then I found if I put like I bent fins in it so that it would turn one way, if it was getting inertia from two different directions, it would turn, and it would spin in the air. It was really incredible. And that's a picture of that's in Gemstone Papers 1. Now, so I was using that, and I went about 30 feet away, and I took a screwdriver, a metal screwdriver in one hand, and I put my other hand on the radiator, which was grounded. And all that thing was running over there, and the paper was spinning happily. I would point the screwdriver in that direction, like 25 feet away, right? As I pointed it, the field weakened. And so I realized then, okay, the paper dropped down. I could turn it off from a distance like that. And there was no arc or anything. This was just in the general air. And so I realized that the high voltage particles, they're very sensitive to change. They'll move very easily. And that's when we went over to thinking about the wire and stuff that Moray did, to have a charged envelope up there, because they're very sensitive to voltage changes.
Fantastic. Well, I mean, this is what happens when you just actually do the work. So thanks for sharing that. That's really valuable. About one of my focuses is magnetohydrodynamics, plasma systems. Have you ever actually made some? We've created these things that are like a ball lightning in the reactor, and sometimes they blow up, and they send out these things that they move in a direction, and then other things they don't care about north or south magnets, and they don't seem to care about electric fields. They only care about self-similar objects that are also moving around in the chamber, but they seem to be able to travel much faster than you would expect them to, and they can even cluster into groups and orbit around their center of mass, which is very, very weird.
Yeah,
but they are little magneto-hydrodynamic balls. Like we've actually got a video where one sort of comes round and another one comes out and it starts orbiting as a pair, and then another one comes out and it's three orbiting. We've got this all on video, and I'm wondering if you, in your experience, have ever seen something doing that kind of thing, but at a much larger scale, or have you only ever seen, like we have, these little things?
Well, let me ask you this. Have you got any way to determine the spin of the outside of the field of these little balls, these ball lightnings?
If you're going in the forward direction, so if I'm pointing at the screen, it's going round to the left side of me pointing at the screen. So if you point at your screen and go round to the left,
okay,
the other ball orbit around to the left.
All right. I did an analogy experiment using, did you ever see my Coke bottle experiment with sound waves?
I did. Yes.
Okay. Well, you saw how the spin, the up and down spin of these created balls that were floating out there in an artificial looking gravity field, they would bounce off each other if they were spinning in opposite directions, but they would cluster together if they were spinning in the same direction. And I'm wondering if that applies.
They do, and you can do this with have you ever seen a Tibetan singing bowl, a really good quality one that has the varying wah 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 frequency when you're doing it by sweeping around the outside? Have you ever seen that filled with water? Because it does the same thing that you demonstrated.
Tell me that again, just slowly. I couldn't quite get all the words.
So take a Tibetan singing bowl.
A singing ball?
A singing bowl, like a bowl.
Oh, yeah. Okay, yeah, go on.
And then you fill it with water, not completely full, but so there's about an inch around the rim if you've got something that's about 1.5 foot across bowl. And then you run the gamma around the outside with the suede on it, and it produces standing waves in there. And then the standing waves produce these balls.
Yes, the same effect, generally the same effect.
Yeah, and there was a Russian guy that showed it, that these solitons, the vortex solitons that are formed under the water, they can leap up and come out of the water. But also what I noticed is when they came down on the water, they could either move around on the water, or if they came in, they were like, the vortex were, horizontal with the plane of the water, they would travel along the water, and then if they had another one coming the other direction, they would bounce off each other.
Yes.
It's amazing to see, and it's because it's maintaining the vortex inside.
Well, look, I could let my frequency run. Instead of having the singing ball, I was making speakers that were vibrating up and down, next to the Coke bottle, which is vertical, and it was just using sound in Coke bottles because the color of the water in there allowed me to film it all. But that's the same thing exactly.
Yeah, and I was amazed when I saw the demonstration, because I thought, okay, so this is all lining up, because we have an experiment that a 3-year-old can learn to do in 7 minutes, and it's using sound just like you were using, but it's using ultrasound in a standard ultrasonic cleaner that you can typically get for about $35 on Amazon, right? You put aluminium foil in there, and you have to have water above and below. So the aluminium foil is sitting in the column of the water. And then you have a hard reflector surface above. We use a piece of perspex so you can see through it. And you know what happens? Within incredibly small amount of cycles, you get yin-yang structures forming. And on one side, you get lighter elements forming. And on the other side, you get heavier elements forming. It's freaking magic, Stan.
Well, it fits with the theory of ether space. You know why Einstein's relativities were skewed as far as proving that there was an ether space. he
No, please tell me. I'm not sure I understand what
well,
you're saying.
Einstein used the Lorentz Fitzgerald what do they call it? Lorentz Fitzgerald transform to plug a hole in his E equal mc squared equation, because without that he couldn't generate the mathematics to make relativity like it was or is in his thing. But this all was based on the Michelson-Morley experiment, which was
Yes.
say.
I was mocking it with a cough. Carry on.
The Michelson-Morley experiment was the first evidence that there was no ether, but later Michelson and Deyo formed an analog, a rotational analog version of it, and it was so accurate they could detect the speed of light of a aircraft carrier down below decks. And they could detect the direction of that aircraft carrier by the or fringes that formed in the Michelson-Morley type experiment, but with not a static one, but a rotating disk. The analogy is this: look at a bucket of paint, thick paint. You put your stirring rod down it and you stir that sucker up, and then you drop in some floaty ping pong ball or whatever, little small floaty thing, and you drop it into where you've created a standing wave between the edge of the bucket and the stirring rod. And when you do that, what you've done is you drop that little ball in the middle of waves going out from the center, bouncing back from the bucket toward the center, and they overlap, and they generate a spinning curl in that standing wave. Now, gravity, in that case, if you're looking at it, there is a gravitational effect. If you try to move that ping pong ball closer to the center or further away, it will gravitate back to that neutral point or that null point where the standing wave is. And what the mistake was when Michelson and Morley did their first test, it was static. It was on the table. They tested the inline direction of the light against the right angle reflected version coming back, and they could get no change, indicating there was no ether or no resistance to the path of light. And the problem was they were looking for us moving through the ether. They were not looking for the ether moving us.
Yes.
And that correction, when you correct it, then you can go to hydrodynamic model a lot easier. In 1958, a group of physicists, at Chapel Hill, they assessed different ways to approach relativity or to approach how the universe works, cosmology. And 40-some-odd% of the attendants said, we need to go to a hydrodynamic version. It's obviously a fluid. And they said, well, we'll have to table that because we don't have any mathematics to solve that. So eventually we came into computer age where you could use, number crunching to simulate fluid motion. But that's, there is an ether, and everything you see, galaxies, galactic cluster, stars, atoms, subatomic particles, all rely on spin around a spin, around that spin center. And it's a vortex that has a north and south pole. The energy comes usually from the center of that spiral out toward the outer edge of its effect. It curls back. And the reason is because when you have such relatively high speeds of spin relative to the ether, you'll get an inertial wall around them. The stuff they spin out at the equator bounces back from space and curls back into the polar regions. Let's see. I guess we could use that. I think. Let me just think a second here. That was on that one. Yeah. Okay. Simple way to look at this is take a bucket of water outside in the garden, 10, 12 inch mouth on it and about a foot high. Fill it full of water. Take your garden hose now and fit it with, put it on hard, straight spray rather than spread out spray. It's a hard stream coming out. And then grab that hose, maybe about a foot 1.5 foot away from the nozzle so that you can dangle it. Turn the water on to high speed stream, start with, and then hold it over the water in the bucket, and you'll feel the thrust of that water being ejected, kicking your hand up, right? Now, the minute that nozzle is lowered to where it just touches the surface of the water, it will suddenly reverse direction and suck it straight down to the bottom of the pail, like bam.
Right.
Now,
yeah.
Why is it doing that?
Because it's creating hydrodynamics as it goes into the fluid.
It is pushing fluid ahead of it that curls back around to form a pressure wall behind it. This is called asymmetric propulsion. And you can use that in gravitics, in fluid dynamics, and various other things. It's in fact, I found one oil drilling company, I think. No, they were drilling for water this time, yeah. But they were using that kind of a thing to go down and tunnel down into the subsurface, layers of dirt and whatever, and they would just scoop it out and push it right back up the pipe around the nozzle. They didn't have to drill or anything. They just used high pressure water. Anyway, that's
a great description. I was describing the other day how people in China cut through 0.5 meter of mild steel using an HHO jet, because they actually have it so that the HHO jet is just a fraction, a couple of millimeters above, and you get extreme hydrodynamic shear as it comes out of the nozzle. And because it's the charged plasma, it then produces this hydrodynamic vortex, which produces this incredible coherence, and then it just goes straight through 0.5 meter of mild steel. It's amazing to see.
So obviously then you're aware of the torque that occurs in a DC welder.
Yeah. I'm also, there's a thing called the cavijet that was invented in Russia for the mining, and they actually, rather than using the pressure just as a pressure of water jet, as you was describing coming out of the hose, they actually had a nozzle that then produced a resonant pulse, and because of the shape of the exit nozzle, it produced solitons, and the solitons were using the same input pressure, the same power, but the solitons were stable, and they could drill the oil well 4 times faster, because it's like a water hammer effect, but it has the hydrodynamics.
You'll find that that everything is not constant power to produce motion or whatever. In nature, it may not be that obvious, but in man-made things, we can pulse, interrupt, and we'll get a much more efficient drilling machine or propulsion machine. Some of the planes that people have reported, some of our research planes in the sky, have a knotted contrail. It's like a rope with knots in it. And that's because they're pulse jetting. They pulse, then they fill the tank, then they pulse at a high rate of speed, and that's a pulse jet. And a lot of nature runs on DC, or like one directional type things. Even
right.
Oh, okay, all right.
Yeah, so bees do the same thing, don't they? Birds do the same thing. They're not continuously producing flow. They're beating their wings.
Yeah. You watch them drop down a bit, then they hit them again, then they hit them again. It's a loop, or like a bumpy road. You see it.
So we're talking about propulsion now. I guess then, how would you most simply describe how you imagine some of these claimed UFO objects that are not pure plasma orbs like a ball lightning, but that they actually have something inside them? How would you best describe, in a kind of like summary way, how those things are propelling themselves?
Well, some of them of late have left me guessing, like these. The one reported, probably 15, 20 years ago off the coast of California, that was like a flat plate, a rectangular plate that came in off the coast there and went over the base. And it didn't have any of the normal markers for, a vortex or a spiral field. So how did that happen? Well, I don't know why they would want to make something rectangular, but they could make a rectangular box that's flatter than tall, and you could put inside that box. You could put all these electrogravitic craft I mean, you know, you could hook up a chain of about 40 or 50 of them, lock their fields together. And so all these little tiny things are propelling the whole outer skin, which is like a disguise. That's the only way I can figure it. Now, triangular craft, no problem. I can figure out they have the central core, then they have each corner by varying the rate of spin on any one or both or all of those corners. They can get a plane of operation. So, but there are things that are puzzling, like little tiny spheres. I've seen one of them in action, and they're shiny spheres, and they move like the clappers, and I couldn't get photographs of it because it's too quick. But here over Cheyenne Mountain, over NORAD, one afternoon after lunch, and I was suitably impressed, and I've heard reports of it and seen films of it over in the Afghanistan theater. So how do you make a ball like that? It doesn't have any, I mean, I guess why? Why would they do that and not just stick with a standard toroidal thing, or like a flying saucer type thing? And how did the like tic-tac jobs work? I mean, why did they make it long and cylindrical like that? What keeps the field suspension, up at altitude, and what makes it propel left and right. So I think they're all functions of electrogravitics, hydrodynamics of some sort, but I just don't know the engineering side of it.
If you were to think that the
ether... Can I interject here just for 1 second?
Go on, Ray. Yeah, sure.
Because I've got to go very, very soon. I've got a call, important one I've got to take. Good evening, Stan. My name's Roy, and I'm from the UK, like Bob.
Oh, okay.
I'm a theorist, a physicist. I have a framework, you're skipping around it all evening, which explains those hydrodynamics, but in a temporal context. In that my framework, a holographic geometric framework, proposes that time is extended from the conservation of what I consider to be emergent time, which gives us essentially a fifth dimensional hydrodynamic dimension. So those ether, as it were, and those hydrodynamic properties are fully laid out in my calculus. You were saying you don't have the math. Well, we do now.
Right.
Okay, so but it's very interesting. You were mentioning about the temporal properties and so on. I would consider that because of that temporal extension of hydrodynamics, then the laws of hydrodynamics apply in that one gains a temporal differential inertia from the differing rates of time. So if you were to experience faster relative rates of time, you would lower the inertia of gravity significantly, and therefore the inertia of you.
Well,
have you considered those issues?
Well, I think so, Roy. In a different.
Bring those to your attention.
Are you still there? Okay.
I am.
The way I try to give this description of how gravity works and how this time differential works, I said, if you have a craft, a jet craft or whatever, something that can turn a corner at 20,000 miles an hour, first of all, it would break all apart and it would kill the crew.
Yeah.
Okay. Your wish is, I wish I could take that corner at a slower speed. Okay. With the 30-foot diameter crafts that people have filmed and things like that, inside the craft, the rate of vibration, like the energy that's pumped into the atoms of the entire craft and crew, is nearly 5,000 times normal density here on Earth. And so
it would be with that inertia.
Yeah. And so you've got that high speed inertia. You're inside the craft and you're saying, look out the window there. See those people? They're supposed to be running. They're all in frozen slow motion relative to our being able to sense time. And so we'll break out the card, have a cup of tea as we turn this corner at 20,000 miles an hour. We will turn it over several hours, but down on the ground, they will see it as a flash in a fraction of a second.
Instantaneous. Yes, exactly that.
So I guess we agree on that, yeah.
Yes, so I'm judging it essentially as a femtosecond relative rate. Essentially from what I see is emulation of the underlying geometry in the one's properties to note the behavior outcome of you invariantly.
Your work is good, and I'm sure there are other scientists and engineers who have pursued various anomalies like this to explain the universe. But I noticed that somebody...
I found very few, actually.
Well, one of the things I found in researching government records and papers and in the National Library, they have sections on high voltage electricity and magnetic voltages, like low voltage effects. Now, in 1958, I think it was in May of 58, suddenly the papers that were submitted on high voltage physics, it just became stagnant. And the one next to it on electromagnetic phenomena, electrostatic, it grew over the century, over the decades, and the high voltage one just shrank. Why? They didn't want people poking around in that because of the effects they'd already found. So whoever controls that made sure that the Library of Congress did not carry the research papers.
Yeah, I can see where they off-branched physics essentially. Through string theory and all that regard, and actually earlier now, because I went back through it and went and looked at it and said, well, where did they get it wrong? And you can see it quite clearly that it was a deflection. Don't look at this, look at that. That was clearly going on.
Oh, definitely. Yeah, our wisdom is sadly locked in amongst a few of us here because you just have no avenue to get that out to the general public.
That's the issue. And I'll hand you back over to Bob because I've got to
Okay,
go.
Roy, good talking to you.
We must talk. I must discuss this framework with you because I've actually solved all the problems as well. According to the DESI and the large, the James Webb and the results of the early cosmos and all of that sort of phenomena. And now even the Royal Astronomical Society is saying, look, it's a timescape cosmos out there.
Yeah.
So, it's absolutely nailed. And well, that makes me number one at the moment.
Roy,
so it's great to meet you. Okay?
Well, just before you go, remember that the speed of light is not constant. It's
all dependent upon the medium.
10 with 60 zeros past it at the beginning of the Big Bang and slowed down on a decreasing a geometric curve. So our time is all screwed.
Yeah, I call it emergent entropic time.
Okay.
Essentially.
All right.
Okay,
Yeah, that works.
Time is an emergent phenomena of a boundary condition, essentially.
Yeah.
Whereby the density of the boundaries restrictions to the underlying change of information denotes the length of time and therefore the flow rates of time and so on in the high dimension.
Yes.
That gives us differentials that require us to unify gravity.
We'll talk again. I got some other questions. I know you got to go.
Yep, I got to go, but I really do. I've got about 30 seconds. Okay, good evening, gentlemen. I'll hand you back over to Bob, but I'm going to follow you, Stan, and do get in touch.
Well, my email is standeyo@standeyo.com. So if you want to email me too, that might work.
Will do. I'll send you the framework over. There's a few videos as well that go into it. And AI has been diving deep into it as well. And even it's agreeing that it's sort of like, yeah, this really does shake up the textbooks, as it were. And like I'd like to say to everybody else, turkeys don't vote for Christmas, so they're not going to be shouting about it.
Yeah.
Okay.
Yeah. Good point.
Good evening. Peace and much love to you all.
Much love.
And back to you, Bob. Sorry for the interchange.
That's all right.
That's fine, Roy. Thank you very much for that valuable contribution. It's it's speaking to what you were saying, Stan, about being inside these structures and time being variable, and obviously this medium that we call the ether. I guess if that's part of how time is able to be changed, or it's a component in that. What do you think the ether is as an actual thing? And how does it allow, for instance, the light to travel through it? Is it directly through it, or is it a manifestation of clusters of the ether? Or what do you think is the ether?
Well, the ether is a fluid of some sort. It behaves like a fluid, but a fluid has to have particles. So what are the particles that make up the ether sea? I have no idea. I just operate on what we know at this point. For light to be propagated through this fluid, it is propagated as a toroid, a smoke ring, if you wish, of inertia in the ether space. This is why it acts like a wave in some cases and a particle in others, because it is a particle that has spin around its own forward axis. Just imagine a smoke ring, and that smoke ring at high speed, it starts to create a low pressure area ahead of it and then form a compressed area behind it in space. So that if it starts out with the energy of whatever produces the light, it's going to take a long time for it to lose energy because it's all being reflected back into its curl. So it really should. I mean, the diameter of it may change, but the curl still stays there. That's why laser being spread out finally.
That's wonderful, because Dan, what you've described there is exactly how I think that the traditional understanding of how a vortex soliton, a ring soliton, propagates through a medium. And is that kind of your understanding of this? What I envisage is this kind of depressurization in front, just as you described, of the medium, which may or may not be the medium through which gravity is manifested and through which inertia is manifested. And that is pulled round and it's fed back in. And I call it feeding up the arms.
Yeah, exactly. I mean, it's the water bucket and the water hose scenario. Exactly. You propel a wave ahead of you. You push ahead. If you want to go ahead, you push ahead, and it curls around and forms a pressure area behind you. At the same time, lowering the pressure ahead of you, and you drop into that.
So this speaks to those people that would say that these so-called MHD-based propulsion systems, the faster they go, the faster they can go, is a phrase I've heard before. Is that something you've been familiar with?
Yeah. Another point to that, when we were devising a version of this concept in powering torpedoes or boats, we found that as you are in stationary position, you turn on the thrusters going ahead of you, that it'll be tugging at the reins to get going. You'll hear it going, and the minute you let it go from the dock, it'll go, and it'll be loaded down, because in the intakes we were taking the energy from the reflection in the front back into our intakes, and we were loading the blades. So it was two things. You either had to develop a software piece in there to lower the input volume going into the thruster, or you had to pulse the thruster. Go, squirt up, have a bunch of water in your tank, squirt it out and ahead of you, close the tank so nothing can get in, and then the next second when you're moving, open the tank to fill it up again, and then close it, and then squirt, and that's a pulse jet. Or like a pulse propulsion, probably how they do the knotted rope thing. But yeah, you have to have the frequency of the pulse to make it happen easily. Otherwise, you just choke your system.
So just a couple of other things that I'd like to talk about, because there's obviously a lot of people here, and I imagine a lot of people are chomping at the bit to have.
It's yours, Bob. It's yours. You got it, bud.
Okay, well, I have to say thank you very much. We have seen, have you ever heard of the toroidal moment?
No.
Okay, so have you ever heard of the anapole moment?
No.
Okay, so the anapole moment was Yakov Zeldovich in 1954, and this is where you have an electric dipole that oscillates, and you then have a ring magnetic current with a toroidal magnetic field that also oscillates, and they phase cancel at what's called a non-radiating boundary. This produces what Ken Shoulders called, in his conclusion of his book Into Exotic Vacuum Objects, a perfect oscillating monopole. These structures are what he calls they're effectively microball lightning, but they are the basic kind of exotic vacuum objects, and they can cluster in two rings. And in his patent in 1991, he describes effectively these structures could be toroidic in their internal dimensions, and that they then form these rings, and then the rings can also form chains. He's a little bit unclear in what the internals of the basic exotic vacuum object is, other than to say that it is like an electron gas, and that it acts a bit like a black hole. Have you ever thought in terms of, what is actually inside, and I know I've asked you about the ether, but in terms of, is it just ions? Is it electrons? What is the overall structure of this magnetohydrodynamics in a plasma sense?
Well, again, Bob, you're asking me to define ether space, and you go down to some imaginary level where it's a particle that can be moved that has probably no charge, if I were guessing.
Okay, so let me fill you in then. So the toroidal moment was discovered by Dibovik in 1965. It was published in his thesis in Dubna in 1967. It was verified in the West in 1997. It's only become part of mainstream papers in major journals in the mid-2000s onwards, and it's picking up pace.
All right.
But one can talk to the other, and it can talk through this non-radiating boundary. And the non-radiating boundary is something that does not emit electromagnetic waves because they phase cancel at the boundary. So you actually end up with something that's a particle, but internally it's a torus. It's an electrodynamic torus. But these things can speak to each other through the scalar and vector potential. So they can cluster, they can organize, they can arrange themselves. And the Russians believe that the ether, the fundamental component, is an oscillating inductor capacitor dipole, which is the model of the Yakov-Zeldovich anapole, and the anapole is the special case of the toroidal moment. So when you're creating a plasma that has got a spin going through the center as a magnetohydrodynamic plasma, that spin is able to start interacting with these elementary LC dipoles, relic neutrinos, and that is what they believe is the ether. So I was just interested to see if you had a different take on it, because some people have ideas and they sound good, but like are the Russians right in this? They at least have an answer for what the ether might be. Does that make sense?
Well, neutrino in classical physics, neutrino is supposed to have no magnetic field or charge. Is that right?
Yes, and that's what you observe from the outside. Now, a normal neutrino has essentially no interaction with ordinary matter. However, at Protvinov in Russia, they had a 70 gigaelectron volt line which fired into aluminium target. This produced mesons, which decayed in a 164 meter vacuum chamber that then went through 49 meters of pure iron, and then it went through a spark chamber, and then it went into 7 cubic meters of freon or whatever it was. It was at 20 atmospheres with a 12 centimeter window, and they recorded over the period of time of experimentation in the world's largest ever bubble chamber nearly 2,000 neutrinos and antineutrinos in total, but they were relativistic neutrinos. The type of so neutrinos exist. That is 100% proven by those experiments. The neutrinos I'm talking about are what are called relic neutrinos, and they claim to be left over from the Big Bang. They're all at 1.95 Kelvin, and they're universe wide, and so that's why they believe in the one condensate. So, and it's a superfluid. So it kind of speaks to what you're talking about when you're saying that the ether must be a fluid. Would you consider it to be a superfluid?
Possibly. I do know that neutrinos have been proven, probably 40 years ago, to deflect in a very strong magnetic field. They are not neutral. Right. So there's something that we don't understand properly about neutrinos, and that could be a superfluid status. I looked at, I study all kinds of things, chemistry, religion, physics, whatever. And in the Christian Bible, in the book of Revelation, it talks about the end of the earth and the heavens as we know it. It will pass away in a fervent heat, and there will be no more heavens, no more earth. Yet a new heaven and a new earth will be created after that. Now, if you look at the spin moments of all the atoms in our universe, if you somehow decrease their spin or cancel their spin, they age out or whatever, together, they're going to release a lot of infrared radiation, and you're going to have a sea full of infrared radiation, which might be, everything being consumed in fire or whatever out there, according to the biblical forecast. So that would say then, if they're correct in that the universe is in entropy at the moment and running down, which is interesting.
I love what you've said then, but it just got me thinking of spontaneous human combustion. If you had a coherent state in a human, you're saying that if somehow the human consciousness was interacting with the spin state of the matter in their body, that maybe that they could release a lot of thermal photons and basically cook themselves. I don't know. I was just riffing on your idea.
Yeah, it's an interesting thought. I've wondered about that that event or that effect, whether it was something external in the body, or whether, I mean, the fact that it doesn't release enough heat to burn the room, but leaves char marks around the room.
Yeah, amazing.
It's like it's the body's being tricked into producing a separation of two chemicals that, when united normally outside the body, would produce fire, potassium and water or something like that. The elements needed to produce that combustion are within the body, but they're tied up in chemical bonds. So I don't know. It's just wild thoughts.
Well, it's good wild thoughts, and sometimes those flights of fancy lead you in interesting directions.
Yeah.
Okay, so I think that where I was going with my previous argument is that the toroidal moment it first occurs where you get an electric ring current that produces a magnetic field through the azimuth. If you rotate that 90 degrees and you have at least two producing a ring magnetic current, it then produces not an electric field again, it produces this toroidal moment. And if you take that structure and rotate it 90 degrees, you then get a second order toroidal moment. But what you end up with, it turns out, is when you have a wheel within a wheel, you get a closed pointing vector. And with the closed pointing vector, you can end up by accruing energy in a locked piece of space-time without any dissipation of it. And so it's like your hydrodynamic, magnetohydrodynamics, but it is fractal. And we've actually produced these in the lab, and we've actually produced the collapsed wave functions. And when I shared this with some Russians, they then shared this classified research, which was outed in 1995 and in 1993. And then it turns out the Americans had done it when they were describing ball lightning in 2009. I would love to have an opportunity to share this material with you, Stan, because I think you could provide unique insight from what's going on.
All right.
So it's about nearly 1 o'clock in the morning. I'm probably keeping my family away. So I'm gonna bow out and say it's been an absolute honor to have this time with you, Stan. I fully respect it. You know, when I saw your presentation fairly recently, and I don't know when it was from some time ago, I thought, oh my God, oh yes, yes. And so I don't know how you learned what you did, but you're bang on the money in so many things you said. So thank you very much, and I tip my hat.
Thank you very much for that, and appreciate being able to fellowship with all you people of like mind. Not very often you find people like us walking down the street.
Well, and I think that was a problem that people in these kind of bordering and almost certainly esoteric areas of thought and science, you often find yourself with a lot of what my friend calls Agent Smiths popping up and saying, my textbook said this isn't so, therefore you must be mad.
Yeah. Look, I try to explain some of the field effects of gravitational spin to a university professor at Western Australian University, physics teacher. And he said, you just can't say that. And I said, look, here's, field effects do work. I said, if you have a hot air balloon, that can stay suspended for, 30 minutes or whatever, on a single charge, and it might weigh a bunch. So an aircraft or spacecraft can create its own field bubble and hang there like it has been reported. And he says, no, this is impossible. That's specific gravity. You can't say that. And he threw an eraser at me at the board. And that was the end of the discussion.
And what you've literally just said is in a patent from early 2024, and they're called vacuum lifters. I'm not talking about hot air. They have a Archimedes spiral of a closed tube that's bound on the boundary of the tube to make an enclosed area. And they have a pump on the outside that pumps and produces a vacuum inside, but the tube, which forms the sphere, is kept at pressure. So it maintains a sphere with a vacuum inside. It's called a vacuum lifter. It doesn't have hot air. It doesn't have, what's lighter than hydrogen? Well, nothing.
That's even better yet. Yeah.
Great. And it can stay up there for basically ever. And it just needs a little bit of power to run the pump to keep the vacuum in the internal volume and the high pressure in the tube, which makes up the enclosed space.
Fascinating.
It doesn't need gravity. It's called a vacuum lifter.
Wow. Didn't know about that, but that's certainly good to hear.
So I'm going to bow out now, honestly.
Say hello to the family tomorrow at breakfast.
Thank you very much. Bye-bye.
Bye-bye.
Excellent. I hope that was as enjoyable for you as a speaker as it was for me to listen. I realize that you it may be your evening, and not for lack of questions, but I want to see how you're feeling on time, or where you're sitting here, Mr. Deyo. I'd be happy to.
Well, a few more minutes. The wife has just finished a nice corned beef meal upstairs, so we haven't had lunch today yet, everything being as it is, but a few more questions, and then I'll probably have to go.
All right. Well, I wonder if I could just, we mentioned Ken Shoulders, and since you weren't familiar with him, this was these fractal toroidal cluster geometries. This is what Ken Shoulders was working on. He was a contemporary of Hal Puthoff, and they both investigated the work of John Hutchison. And you'll hear in this clip that I'm about to play, he talks about these EVOs, exotic vacuum objects, being crucial to the effects of Hutchison's experiments. Just 1 second, and I'll play a short bit. I think this might stand in.
Ruby stand on the side of the stick poking them. Hey, you guys, those that are really probably not neutrons, you ought to quit publishing that they are. You're killing your reputation. They can't unpublish the results they published already in any reasonable way.
Do you think they are black holes, white holes?
They are black holes, in one of my notes, in that they contain all the characteristics a black hole does. They swallow material, make it go away. That's what they do.
Astrophysics has talked about black holes. From your analysis of John's metal samples, that he had these exotic EVOs operating inside of those transmutated metals.
Now, back up a little further. Yes, I do think they're the major cause of everything he's done with propulsion, transmutation, you name it. They stem from this effect.
So I won't torture you with the bad audio, but I hope that you might be able to hear. He was talking about the abilities of this for transmutation, propulsion, energy generation, also teleportation. He says here. I think it's an important point. Let me just play this.
You want to look at it that way. It's a form of teleportation of sorts, because it can take an entity and put the entity over there. It's superluminal, it looks like. Things go faster than light. We're not bound by that rule anymore.
So I just wanted to play that for you and see if that rang a bell, or if you had any thoughts about,
Star Trek transports are not the way that you're going to see it done, because they require in that fictional setting to disassemble all the atoms, et cetera, and then project them to a place and then put them all back together again. There are so many things that complicate that, like the amount of energy required to break the van der Waals, bonds between atoms and stuff, that is just horrifically ineffective cost-wise to even try to do that, which is very dangerous. It is far more simpler to charge the space around an individual or thing you're trying to move, and move that whole space intact. There was a block of iron sent across the room in the White House back in the early 50s, as a first experiment of teleportation. They didn't disassemble it. They just charged the area around where it was and moved that charged space over to the target destination. Now with quantum entanglements, one wonders if we can't use quantum mechanics to move things great distances, which is teleportation. it's interesting. I just don't know, beyond a certain point where it's going.
Yes, certainly. Well, that's a fine answer. I think it might stem from this moving through the medium, understanding that we have something like a polariton on the lattice or something like that. But let me ask you a more direct question about beat frequencies and how they might drive some of these non-equilibrium plasmas, maybe with ponderomotive forces or Langmuir modes, ion acoustic waves. I know I'm throwing out a lot of words, but I'm hoping that you might be able to expand anyway on a beat frequency's role in plasmas.
Well, I must tell you that my experience in plasmas is limited to the propulsion and time dilation things I've talked about. I know that plasma physics is somewhat different to normal physics. My research associate, Ben Astray, he's now passed, but we did look at that as a possibility and setting in beat frequencies to make things travel within a plasma field. And we stopped there. We just ran out of time and money. But it's plasma physics is really getting the atoms, stripped down, and you've got free flowing nuclei and electrons. And this has always been a problem because the Rutherford model of raisins in a cupcake type thing, atomic models, don't exactly hold true. It's more like there's a spin vortex in the very center of an atom, and then there are standing wave shells that progress outward from it. And these shells, in turn, have spins within them that formed the signature of an electron. I saw on the internet, you can look it up, there was a couple of experiments done with water jet technology where they had red dye put into one hose system and red dye in the other one, and they faced the two nozzles at each other and filmed at high speed. As these two streams of high-speed water hit each other, they not only bounced in a sphere around that outward, the bounce waves form secondary curls and stuff, making secondary systems all around like electrons would be. Just look up colored water, high energy water studies or something like that. I'll see if I can find it here because I know I did recover it, but interesting thing to see about the formation of things with inertia. It also explains why when you drop a drop of water on a flat surface, that they don't just splash out uniformly and make a rain splash. They splash out, leaving little spikes going up. And the faster the impact is, you form double spikes at the secondary stage of the spikes. Let me just see here. Just give me a second here. I'll see.
Certainly, please. Yes.
Experiment. Color red, blue. Yeah, I'll go to videos. Maybe just videos. Here we go. Oh, that's interesting. It's not the one. Oh, there's okay. Yeah, right. Okay. Water density. Toroidal. No, it's a different one. Why don't you change my search parameters? Collide. Maybe I can do it that way.
That sounds very interesting.
Well, can you hear that?
I can't. No. Oh, I meant the topic is interesting.
Oh,
yes. Just to turn a phrase.
Okay, sorry. I'm trying to look at this one. It won't let me turn off the sound. Fluid mechanics impact of the jets. Well, no, that's one that might do it. All right, I've got to get through this here. 5, 4, 3, 2, 1, skip. Okay, and this isn't the one I saw, but this is a vertical analog to that. Let me just see if it will do the same job. looks like it might, but it's not the one I want. Sorry.
And that's how it goes sometimes.
Let's see, water jet, colored lighting. Let's do it that way. Red jet, yellow. Let's see, okay. Blue water jet colliding with a yellow one. Okay. Okay, that's in that one there. Let me just see. This is interesting, this one here, but not the one that I wanted to see. What they've got is a red and blue colored stream of waters hitting each other, but at an angle because gravity had taken over. These weren't high speed, so you can't see the effect there that I was talking about. Let's see here. Water jet separates high performance. Yeah, okay. Okay. Well, if I can draw you a mental picture, maybe you can search it out later. They have these two.
Please, yeah, we have good imaginations. So please go ahead.
Tank of red water, tank of blue water across from it. They both feed high pressure water pumps, and they aim these beams of water, colored water, at each other, so they strike exactly head on. And in the video, then it generates this like a plane of splashed water where these two collide, and there are equidistant formations of other curls in the water in that expanding sheet around the collision point, which gives you a clue in the formation of standing waves from this. But it's just important to do that thing. Let's see, I would usually change, maybe it's in my own files here. Let me just check that here. Colliding.
You got it, take your time.
Well, I have about 2.5 million files to go through, so.
I know, I feel like a messy detective. I've got leads buried under leads. If I could just get them organized.
Oh, too true, too true. Yeah, water jet, kind of water jets. Okay. Let's see if we can get it here. Yeah, okay, go ahead. Okay. Oh, it's a restricted site and it's been taken down. Isn't that sad?
Libraries of Alexandria.
Say again?
I said Libraries of Alexandria, lost wisdom.
Yes,
Yeah.
yes, definitely. Let's see, they didn't like that when I did a global search. Let me do a specific one down in the research files. Where's research here? Okay. Yeah. Okay. Contains that. Let's see what we get. Okie dokie.
Well, yeah.
Yeah, go on.
I might take just the opportunity to say it's been a pleasure for me personally and an honor. I'm very grateful for your time, and I hope that this has maybe served you well. I know that on behalf of many listeners who are enjoying this tremendously, they thank you as well.
Well,
there's
glad to do it. Like to share with people that understand. That's really good. I'm just scrolling through some of my files here. I don't know how I coded that name on that, so I'm doing a partial.
Maybe it's Untitled 2.
Oh, get a break. Yeah. Definitely a possibility these days. Let's see. Okay, there's that one there, and that was not it. Name contains water, maybe. Oh, that's a nice picture, but still. I can't share images with you, can I?
No, it's one of the downsides.
All right.
If you, I wouldn't want to send you into, you could do it, but it's complicated. If you would like to try, there's a little purple tic tac in the bottom right. And there, if you click, you can reply and maybe attach an image. but I honestly wouldn't want to put you through it.
All right. I'm just checking to see where. Yeah. All right. Well, look, I better break off and have dinner anyway. But you've got my email. If you email me, well, I'll try to find that link to share with your people, showing the colliding water beams. It is important to see what happens. It explains, splash drops. It explains inertia. It's just you just have to look at it and you'll see what's forming from impacts of inertia, not charge or magnetism or anything. Just pure inertial distribution of energy into either solitons or toroidal structures, however you want to call them. But I'm
Excellent.
seeing that I must be close here. Let me see. Water drop splashes in gravity. Let me try that one. Oh, that should.
All right.
Hold on just a second. Okay. Oh, those are beautiful. Okay.
It's personal now, as my family says.
Yeah, it is.
You're committed.
Yeah, definitely. Here, I'm trying to see here. Let's see. Gravitational physics. That's what's probably going to be. Wrong spelling. That always hurts. Gravitation. Okay. Oh. Hey,
if I could ask you, go ahead, please.
Oh, I'm just saying that AI gets in your face sometimes, trying to figure out what you're saying and changing it. Not for the best or most helpful.
If I could ask you a question while you're looking, I wonder if you've ever come across Prince Hans Adam of Liechtenstein.
No.
Okay, all right. Just that's one of the feelers out there. He was a part of funding Ken Shoulders, who I played, and Hal Puthoff. And Shoulders actually petitioned the Prince to fund John Hutchison. I'm not sure if something came out of that, but he's a figure in this, let's say, hidden science, which we hardly got into, but it's just because there's so much to talk about.
I know, it's a wide open library of questions. 3D Earth gravity images here. Let me just try that. No.
That was pretty phenomenal. You spoke with John Trump and got to meet him and talk about Tesla, by the way.
Oh,
that's in one of your recordings, but so that's phenomenal.
That was before, of course, Donald Trump was on the political scene, but it was actually really quite a good conversation. He's a friendly old chap with a good sense of humor, and got involved in so many of the things in World War II, including super Van de Graaff generators for high voltage effects and what they're doing in nuclear research. But he and Van de Graaff were partners in that. Okay, I'm just running down my last possible thing here at the moment. Okay, Graf. 14.
You never ran across Winston Bostick in plasma research or Friedwart Winterberg in nuclear applications at all?
No.
Was it just feelers?
No, sorry. Look,
that's all right.
Most of this stuff was done years ago now than when I was in Australia. And
you really got separated from the herd there. And there was a lot of stuff going on this continent. I suppose your network is something like a Five Eyes contingent of this kind of operation and managing a program across continents. Is that I'm not saying it is Five Eyes. It's more than that. But is that something like it? That network you were in?
Well, what are people doing the research?
Yeah, I suppose whoever your handler was. Also, your handler was attached to gold. Did he have anything to do with Yamashita's gold?
Wait. How was my handler connected with gold? I don't.
In an interview, you said that he was awarded by the British court for work in getting gold at World War II. And that sounds like Yamashita's gold to me. I wonder if you had any idea.
Did it sink off the island of New Zealand?
Well,
Sir John got it off.
It was a looting of Japan, is what I know. in my story, and I wonder if they connect.
I don't think so, because this stuff was from a sunken ship that sank off the islands of New Zealand, and it was a deep dive. And Sir John had a diving company, and he recovered that for the Queen. So, yeah.
Interesting. You may be aware of the story of Yamashita's gold, a bunch of buried caches that were found out by the OSS and extracted. It's a big story, but it was a part of the funding mechanism for what would become the CIA and their operation.
Oh, no, I wasn't. Another one of those holes in my knowledge. Okay, sorry. Okay, look, I've searched all I can at the moment. I just cannot figure out where I hid those things. I'll probably have to look straight back on the internet. But I do need to go because dinner's growing cold now. I got the second alarm from upstairs.
Yes. Well, let's let you go, and other people up here might just shout "I love you" or say bye. We don't have time for more questions, but you are welcome here, and thank you very much for your time.
Thank you for all that you've done here, putting these people together, and for you people who are joining this. I appreciate that.
We love you.
Thank you. Love you back. All right, now
please come back.
Enjoy that corned beef.
Will, it's the Irish in me, I'm afraid. Okay, I'm going to sign out somehow here.
All right. If you go to the top right, there should be an end
and leave. Leave. Button.
Yeah, leave. Yeah, that's it.
All right.
It's my island, by the way.
Okay, I'm going to go. Thank you. We'll talk again. Okay.
I hope so. Thank you very much. It's been an honor and a pleasure.
It's a pleasure to me too. Bye-bye now.
As above, so below, the human being finds himself, or herself, in the middle. There is as much space outside the human, proportionately, as inside. Stars, moons, and planets remind us of protons, neutrons, and electrons. Is there a bigger being walking with all the stars within? Does our thinking affect what goes on outside us and what goes on inside us? I think it does.
This is a donut.
Is it a symbol for something else?